Today we are going to start a new unit, which is units and dimensions. So units and dimensions. So we are going to talk about them and some of their uses. Okay. So the first topic that I'm going to cover is the types of physical quantities. The types of physical quantities. There are two types of physical quantities. One is fundamental quantity, fundamental quantity, which are independent of others and are defined by something which is permanent or fixed. And another one is derived quantity. Fundamental quantities have fundamental units, whereas derived quantity will have derived units. So let's talk about the SI system. The SI system has 7 fundamental units. So they are independent of any other units, which means they are described by something that is always constant or is known to us. So let's make a table to make this easier for us to understand. So I'm going to write here quantity, here the unit, and here the symbol. So talking about the first quantity, which is length. We measure length of various things: radius, diameters, length of tubes, length of pipes, radius of earth, radius of balloon will be examples of length. The SI unit is actually meter. It is sometimes written like this, or it is also written as metre. I will be using meter in my lectures, and the symbol is m, small m. Another one is mass. So mass is the amount of the mass gives us what a body contains. Okay, so it is measured in kilograms. Okay, it is measured in kilograms and is responsible for weight. So we can write its symbol is kg. And another one is time. So time meaning that is given by a clock, so it gives us a duration, and its SI unit is second, and its symbol is S. Sometimes teacher also write SEC, but its symbol is S. And another one is temperature, which is used to measure the hotness or coldness of a body, and its unit is Kelvin, from Lord Kelvin, which is a famous scientist, and its symbol is capital K. Symbol is capital K. So these four are the most common that you will face when doing standard and normal high school physics. But talking about others, we will also talk about others, which are the next one that I'm going to talk about is electric current, the current that passes through your wires at your home and that gives electricity. So talking about the quantity, it is electric current, and talking about the unit, it will be ampere. That's why you might hear some people say 10 amps, 20 amps, and 30 amps, stuff like that. And another one is the symbol. The symbol of ampere is simply A, capital A. Now the next one is luminous intensity. Luminous intensity. For example, if you have to know how bright a light or a torch is, you can measure it in luminous intensity, whose SI unit is candela, and its symbol is capital C and small d. Another one, the final one of the 7, is quantity of matter. Quantity of matter deals with how much there is. So there might be 20, 30, so quantity of matter. So its unit is mole, mole, and its symbol is mol. The m can be capital or small, it depends on your teacher, but most commonly it is small m. So the next one which we are going to talk about is derived quantities. So we just talked about the 7 fundamental quantities in the SI system. Now we are going to talk about 2 supplementary quantities which are quite important. So supplementary quantities and the units. So we just talked about fundamental quantities and their units. Now we are going to talk about supplementary quantity, their units and their symbol. There are only 2 of them. The first one is plane angle. So plane angle gives you an angle. So what kind of angle may be your question? Its unit is radian, and its symbol is RAD. So I will tell you what these are in a quick second. So another one is solid angle. Its unit is ster radian, and its symbol is SR. The radian in the R in the radian can be small or capital, depends on the teacher. Mostly written in small RAD. So now let's talk about supplementary quantities, because it might not be quite clear for you what they are. So talking about plane angle, suppose this is a circle, or you can take anything, because I'm doing a circle because it's much easier for to do it in a circle. Suppose here let's take this as the center O, okay, and this as an arc. So here this angle which is currently or most commonly written as theta is measured in radians. So this is measured in radians. So now let's talk about solid angle. So solid angle is also it is so this was done for a plane. So now the solid angle will be for a solid. So let's make a solid. I will make a solid. Let's try to make it three-dimensional. So I will try to make it three-dimensional. It might be or it might not be. So let's make it three-dimensional. I think that looks pretty three-dimensional to me, at least. Okay, so let's modify this a bit. So here let's do dotted lines rather than, so let's do dotted lines. So as you can see here, this is a sphere. So suppose we took some portion of the sphere. Suppose we took this portion. So here also the sphere also has a center. Suppose this center is O, and there is a cone suspended due to this. So we have a cone which is being suspended, or which we can see right here, and this cone will have a 3D angle. So why a 3D angle? Because let's draw a cone real quick. Let me see if I have a cone. If not, we will do some adjustment. So let's take this and let's take another shape, this one. So think about this cone. So if you think about this, the cone is curved. So since the cone is curved, there will be a 3D angle. So not an angle like this, it will be a 3D angle, something like this. It's not very easy to demonstrate in real life because it is something about a 3D, but this here, this angle will be measured in sterradians, if it was clear. So this was it for today's video. We will talk about dimensions, dimensional formula and dimensional equations in the next